Once again, this is the second part of the previous video. Alright, on this video we're going to see how we are going to work out the mean, median and the mode for grouped frequency data. Alright, now in the previous video you saw that the categories were discrete values. It was like either 100, 110, 120. Okay, now the categories are grouped. Okay, so they could take a range of values. Okay, so this table I've drawn here is just to say, let's say you go to a primary school, grade 3 kids, okay, and you want to sort of put the heights of their heights in a table. All right, now you're saying anyone who has a height between 100 and 109 would fall inside this category, and 110 to 119 and 120 to 129, they all fall inside these categories. Okay, so let's just put some values there. So let's say there were 6 pupils with that height, there were 7 pupils with that height, and there were 3 pupils with that height. Okay, for grade 3 students. Okay, now how are you going to work out the mean for this? Okay, now you have 6 pupils who have this height. Okay, now so these 6 pupils could have had heights anywhere ranging between 100 to 109. Okay, so all 6 of them could have had a height of 100 centimeters, or all 6 of them could have had a height of 109 centimeters. Now which one do we choose? Okay, so we really don't know what specific heights these 6 students have, so we just have to make an estimate. So a good estimate would be the midpoint between these two values, which is 104.5. so you're going to assume that all 6 students had this height. Alright, same with this category, so I'm going to go for the midpoint there, which is 114.5, and here it's 124.5. so just like in the frequency table before, we're going to multiply our x. This is, sorry, but that's our f. That's our f, and this is our mid x. Okay, mid x value. We're going to multiply this and this. All right. Okay, when I work that out, I get these values. When I add them all up, I get 1802. Okay, that's the estimate of the sum of all these 16 students. Okay, so it's an estimate. All right, so that's sum of fx, and that's sum of f, and the mean therefore is 1802 divided by 16. Okay, and I get that value there. So that's my mean. Okay, so that's my mean. All right, now before we work out the median, we're going to look at the mode. Okay, we'll see what the mode is. The mode is the most frequent category, which is this. So the mode category, so you can't give a specific value, so the mode category is 110 to 119. Okay, so you'll have to give that as the mode. Alright, now we'll see how you work out the median. Okay, now this is actually the most complicated bit in this chapter, working out the median of a grouped frequency table. Alright, okay, so there are 16 people there. Alright, so we got to divide 16 by 2. Alright, so that's the 8th person. Alright, now the 8th person is in this category. Okay, now unlike the mode, we cannot say the median is this category. We have to actually give a specific value. Okay, now the principle on which that works is this. Now let's say, just for an example, if our median was the 7th person, okay, we'll say it's the 7th person. Okay, so 6 people are in this category, so the 7th person will be the first person in this category. Alright, okay, the 7th person will be the first person in this category. Okay, so let me draw this out clearly. Alright, so if you look at the first category from 100 to 109, what we're actually doing is, instead of saying okay, they all of them could have had a height of the mid category value 104.5, we're actually ramping them up. Okay, alright, and so there are 6 people there, so we are creating 6 levels between 100 and 109. Okay, so I don't know what's 9 divided by 6. It's probably 1.5. so the first person would have like 101.5 and 103, and if you keep adding 1.5 you get to 109. Okay, so that's what we're doing there, and the same thing we are doing here. So there's a difference of 10, and then we're dividing it by 7, so whatever that is, so 1.3, I don't know, maybe it's 1.3. So you keep adding 1.3 to each subsequent value. Alright, so the first person you say he has 111.3, the last person you say has 120. Okay, alright, so the median position is actually the 8th person. Alright, so we've gone past 6, so we don't need to consider this category. So the 8th person is actually the second person inside the second category. Okay, and we've got to get a specific value for that person. Okay, now this process is called linear interpolation. Okay, interpolation is you're getting an estimate from known values. Okay, you're getting an estimate. Okay, and those known values, okay, from those known values you're getting an estimate value, and the linear stands for, well, this thing here. All right, it increases linearly. All right, so therefore it's a linear interpolation. All right, it increases like a linear function. Okay, those who do core 1, like a linear function, that's why it's called linear interpolation. So the 8th person is the second person inside the second category. Okay, so you would have to add 2 lots of that value. Okay, 10 divided by 7. Okay, so 10 values, 10 divided by 7 steps, so each step has a value of about 1.3. okay, right. Okay, so you could expect that to be, if it was 1.3, you could expect that to be about 12.6. okay, now then you got to add that 12.6 to the lower boundary, so the median value would be 112.6. okay, right. Now some of you who are already familiar with the steps that you take are shaking their heads, because I haven't been very precise in some of my calculations. Okay, I'm just trying to go through this quickly to give you an overview. I will go through the precise calculation in a minute. Okay, but I just want you to get a good idea of what we are trying to do here. Okay, this is not the accurate answer. Okay, now I'm going to show you how that is worked out precisely. Okay, so the median is in the second class. Okay, which has 7 people in it. All right, so it has 7 people in it. So what I'm going to do, okay, now not many people adopt this method, but it's a very straightforward method, and if you did this for the exam you get full marks. I mark exam papers and I know very well that I've given full marks for this, and mark scheme allows this as well. Alright, so I draw a triangle and I draw another triangle inside it. Okay, so this small triangle compared to this big triangle is a similar triangle. Okay, same form of the same dimensions in terms, no, not the same dimensions, but the same angles, but the ratio at which each side sort of is similar to the other is the same. So if this was 5, the longer one could be 10. So the sides are always doubled. All right. Okay. So what I do is at the bottom, I'm going to, okay, so let me draw the smaller one using red. All right, smaller one's red, the bigger one's white. Okay, right, at the bottom 7 there represents the total number of people in that category. Okay, and 2 represents the total number of people you needed to count up within that category to get to the median. Okay, so it's the 8th person. All right, so 6 people are in the first category, so in the second category you had to count up 2 people. Okay, the second person inside the second category is the median person. All right, 7 stands for the total number of people in that category. Okay, this side is the class width. Okay, now the class width here, you would think it's 9 because it's 119 divided by 10. It's not. Okay, the class width here, alright, now let's say you had a student who had a height of 109 centimeters and 109.4 centimeters. Okay, now which category would you put that student in? You put that student into the previous category here, because if you round up 109.4, that person, you have to round it down. Okay, but if that student had 109.55, you would round them up into this category. Okay, So the smallest value that this category could have is 109.5, and the biggest value that this category could have is 119.5. okay, so that's the actual class boundary. Okay, so you got to be very careful there. Okay, so if you look at these categories, and if there is a gap between the upper value and the lower value of two subsequent categories, then you got to do that. Okay, you got to account for the rounding up errors. Okay, where the lowest person where you round up, and the highest person here you round up as well. Okay, so the two extreme values are 109.5 and 119.5. so the class width is actually 10. Alright, so that's 10 there. Alright, now if that is 10, this person is a second in that category. Okay, so it's very much below the halfway point of 7. Okay, so that person you would expect to have a value less than half of this. Okay, and that value we got to figure out, and that's the unknown value. Okay, that's like this value here, 12.6. okay, 2.6 I should have said, the 2.6 that you added on to the you added on to 110. Okay, but you can't do okay, I'll explain things later. Alright, so this value here is the bit that you need to add on to the lower boundary of that class. The lower boundary is 109.5. okay, the 10th person would have 119.5. the lowest person would have a value close to 109.5. if it was a third or the fourth person, they would have a value like 104, 105. So it is the second person, so they would be having a value close to 111 or 112. Okay, so if it's similar triangles, the ratio between the sides are the same. So 7 divided by 2 is equal to 10 divided by x. Okay, so the 7 from the smaller side is similar to the 2 on the 7 from the bigger triangle is similar to the 2 on the smaller triangle. So these two sides also work out at the same ratio. So therefore x is equal to 20 divided by 7, and x is 2.86. okay, right, so this is the value that you need to add to the lower boundary of the class, which is not 110, which is 109.5. okay, it's very important you get the correct values here. Okay, because you could have a person low as this included in that category of 110 to 119. Okay, so you add 2.86 to that, and you get 112.36 centimeters. So that's the estimated value for the median height. Okay, so it's no good giving a category for the median. You have to do linear interpolation by following these steps. Okay, now you could get a different group frequency table. Okay, now for this group frequency table, now the highest value on one category is the same as the lower boundary of the next category. Okay, what that means really is this, that x could be the variable is equal to or greater than 0 but smaller than, just smaller than 500. Okay, so that's what it means. Okay, now in this case, if you were to do the linear interpolation here to work out the median, so there are 90 people, so the half of that is 45, so 45th person will be inside this category, so that's the 15th person inside this category. So you have 20 there, and you're looking for the 15th, so that's in red. Okay, and that's what you need to find, x, and the class width you here, you just take it to be 500. You don't account for those extra bits. Okay, because this is precisely above 0 and precisely below 500, so the class width is 500. Okay, whereas here, because there's a gap between the class boundaries, okay, here there's a gap here, alright, you'll have to account for those extra values. Okay, so just remember that. Okay, always look at the table and make a decision as to what your class boundaries are and your class widths. Okay, so here you take 500, and any value that you get here, let's say you got x is equal to 300, you would add to the lower boundary, which is 500. So lower boundary is 500 and 300, that gives you 800 for the median. Okay.